Hello and welcome to my Tech Fun. It is time for a product review, and this time it is Artillery Sidewinder X1, and this is the fourth version, the V4. The Artillery company listens to feedbacks and try to modify their product, so we will see what is improved in this version. And one interesting detail, so this package was sent to me by Artillery for the review, and he sent to me from the Hong Kong, and when it arrived, the customs contacted me to give exactly the description, what is inside, what materials. Maybe they thought it's some kind of weapon or something like that, because the company name Artillery. Okay, so it is inside, and let's see quickly the specifications. So it is big 3D printer. The building volume is 300 by 300 by 400 in Z direction, so that's quite big. It has a direct drive extruder, silent stepper motor drivers, which is probably now the standard in nowadays modern 3D printers. It has touch screen, filament runaway sensor, power loss detection, ribbon cables for cleaner cable management. More about that later. Dual Z-axis, Volcano nozzle, AC bed heating, which is new here, and it says AC is good compared to the DC. If it is safe, that it is very good because it can heat up the printing bed very quickly. So for example, in specifications it has 110 degrees Celsius can be reached in only 130 seconds. Maximum temperature of the bed is 130 degrees Celsius. It has inductive and stop sensors, which are probably more precise because they don't have so many moving parts compared to the mechanical switches. And probably the lifetime is longer. I'm not sure about this second one. This specification you can see on the website. What you cannot see on the website, but it's there, that it has manual bed leveling, which is now even more important to do it precisely because we have now bigger volume, a bigger surface area. On the official website, I couldn't find the information about the maximal temperature of the nozzle. Then I saw on different websites, on Banggood for example, there they write that it's up to 240 degrees Celsius, and this makes me think that probably this nozzle has the same structure like Cura printers, where the Teflon tube goes completely touching the nozzle in the hot end. And this time this means that we have that limitation because the Teflon tube, it's not good to heat it more above 240 degrees Celsius because of the fumes and similar. There are some better quality tubes like Capricorn tube. With that we can raise this temperature a little bit more, but we will see what's included here. Okay, so let's see what's in the box. Packaging looks very good, so let's take off the first layer. Very detailed instruction manual. As you can see, it's quite pre-assembled. So this is the main bridge, and even stepper motors and timing belt on the top is assembled. Cables. Filament spool holder, that's a small bag with the tools and additional cable, USB drive, a spare ribbon cable. I hope I will not need that, and the base. And I think the box is empty. So the installation manual is on several languages. Step 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 steps. So first let's see. Step 1, just to place this bridge to the base and connect with the 4 pieces of this M5 by 45 volts. I will rotate it on this side because here I have less electronic on that bridge. So the bridge is assembled, but I want to see what is inside. I have to take off these bolts here, but I don't recommend you to do this, otherwise you will lose the warranty. Yes, I will lose the warranty too, but I cannot resist. I want to see what is inside. Okay, so oops. I cannot remove it completely. I have to deattach the fan here. Okay. So this is the power supply unit here. Here is the display and here is the main board. Let's take a closer look of the main board. So it has 5 stepper motor drivers, so the Z-axis stepper motors has different dedicated drivers for it, but they are connected with the timing belts, so they cannot be driven individually. For example, to the left and right side with moving only on one side of Z-axis. And this is the display from the back side. Step 2, spool holders. So this is the spool holder from 2 sides and it has to be attached from the back in this position. So I'm not sure is it visible on camera, so here we have these T-nuts already inserted in the slots, and all we have to use the M5 bolts and attach this holder to the T-nuts. And it's adjustable, but more about that later. So this is how this spool holder works. So we have these very nice ball bearings, and then we can adjust the distance and place a spool, and it will roll very nice on these ball bearings. Now the problem is, if you are changing the spool and you have different width, in that case it's not tied yet from behind, so you have to unloose at least 2 bolts from the behind, change the distance between these 2 holders, and then you can place different spool. A solution for this could be maybe some kind of pipe which I can place here on these 2 ball bearings, and in that case, independent of the width of the spool, it will always sit on those rollers, similar like inside those rollers in the filament drive, Sun and E-Sun. I presented them a few months ago. Step 3, connect the cables. Let's start with the filament runout sensor. The other side of that cable is somewhere here, but let's move the Z-axis higher a little bit so it will be more comfortable for work. So I don't need these zip ties anymore. Now by rotating these 2 lead screws together, I can lift higher the Z-axis. The Z-limit switch cable. Z-stepper motor driver cable, there are 2 of them, so here and here. I will use some Kapton tape to glue it. X carriage cable. Just pressing it inside and that's it. Okay, I hope it will hold it. And same on the other side. And then connect the X-axis stepper motor. And next step is to tighten all tension wheels. So as you can see, if they're not tight, this is quite loose. Now, I'm not sure if you are familiar with this method. These are fixed wheels, and one which can be tight, eccentric, is from the other side. Let me show you with this one here. So these are here fixed wheels, and the extension wheel here is on the other side. So I will need the open-end wrench, and I will rotate it until I get the good tension. And I cannot rotate freely with my fingers these wheels. So from the bottom we have three wheels. So here on the left side they are fixed wheels, and here on the other side they are eccentric, so I have to rotate each of them until I get here good tension. One of the eccentric nut completely rotates. I cannot tighten it at all. It makes full circle without any tension, so I have to take off the printing surface. Be careful, at the end of this bed is the AC cables. We don't want to break it. I will move the Z-axis a little bit higher. Now I can see the problem. So this nut became loose completely. So I replace that nut with this one here. As you can see, there is a plastic for the locking, but this one is regular, so I have to use the washer with it. Now the replacing is not so easy because I cannot access from the other side with the Allen key, but I will try to lock it with the pliers and then lose this nut here. Actually, by removing these two screws I can take off this part, and here I can slide off the printing surface, and then I can access freely to the other side of the wheels. And now I can tie those eccentric nuts. Okay, now all three eccentric nuts are tight now, and I can place back the heated bed. But since I'm here, quick check those yellow springs with the flat surface. So it's very good that they use these ones. Approximately 25 millimeters length, approximately 10 millimeters in diameter. And be sure that you cannot move freely with your finger these wheels, then it's tight correctly and it doesn't wobble. On all four sides. So all eccentric nuts are now tight. So I have here one from the X-axis, one on each side from the Z-axis, and three, you saw it before, on the Y-axis. It's from this side here on the bottom. And now I can move to the next step, connecting the power and turn on the machine. Now, according to the manual, I have to heat up the nozzle and the bed, but first I want to see if the moving is okay. So I go to Tools, Move, and 1 millimeter is okay. Let's try the Z-axis. It's working. Y-axis also working. X-axis also working. Okay. So axes are working, so here inside the tools and move. So here I can move the axis, I'm going in back now. And according to the manual it says go to tools, heat. Let's preheat the bed to 50 degrees Celsius. And the nozzle to 180 for now. And here we can monitor the heating. Now before I start the leveling process, I want to be sure that nozzle will not hit the bed when this limit switch, or not switch, sensor will be activated. So I will just move it manually down. And it touched the bed now, but it's not activated yet. So I will squeeze the springs. Maybe I can lift higher this limit switch. So I compress the springs as much as possible, well, almost. So the nozzle is approximately 2 millimeters, 3 millimeters from the bed. And now the LED is active, and it is still approximately 2 millimeters from the printing surface. Okay, so now the homing will be safe. So it is not automatic, but it's not completely manual, so it's some kind of manual assisted bed leveling. When I press this button, any of these, it will move the nozzle in that corner above that knob, and it will ask to rotate the knob until I have that paper friction between bed and the nozzle. Let's try, but I have to zoom out the camera. So it is above the first nozzle knob, and then I have to rotate the knob until I get that friction. The bed should be leveled now. Let's try the homing. Home separately or all at once. Okay, I'll move the Z-axis higher a little bit. Next step would be the slicer preparation, but before I continue, let's analyze a little bit the hardware here. So this is the front of the printer. We have here the touch screen, and we have here place for the small SD card and the USB pen drive. On this rail the Y-axis is moving, and of course we have here the bridge, and here we have the spool holder, which I will try to modify a little bit. I want to add those kind of pipe or something like that rollers here. And from the back side we can see the Z-axis. So as you can see, we have two lead screws on the Z-axis, and we have two stepper motor. And on the top we have the timing belt. It's a little bit loose. I don't know, it would be good to have some kind of tensioner here. It looks like I have to print some. And on the side here you can see this, this is the X-axis gantry, which moves up and down. The stepper motor for the X-axis. And this is the direct drive extruder. And you can see the gear ratios. I hope it's visible here. And a very nice cable arrangement thanks to these ribbon cables. Tension is good. I'm not sure where should I adjust the tension. Maybe unloose these two bolts from the bottom and pull it in this direction. And here we have connection to the USB. And that's it. So two things I want to immediately modify, and that's the spool holder, and add some kind of tensioner here. And why is this timing belt important? Well, two-stepper motors keep the Z-axis lead screws in synchron completely perfect, without any problem. The problem will appear when the machine is turned off. In that case, I can independently rotate one or the other. Well, theoretically not independently, because they are connected with this timing belt, but if it is loose, then we lost that precision. It's time to print something, but I have to prepare my Cura slicer for the new 3D printer. Go to Add Printer, search for Not Network Printers, and in this list search for Custom Artillery and Artillery Sidewinder X1 printer. Now on this page we don't have to change anything, we can just check are the dimensions and other parameters correct. And this is the extruder data. Just click next and insert some object, and I will just click the slice to prepare the G-code. And I will copy G-code to the USB pen drive and try it. Bed to 60 degrees Celsius and the nozzle 200 for now. I'll try my first printing from the USB pen drive. Calibration cube confirm. In the meantime, this is what we can see on the screen, and I know I can maybe change the nozzle temperature. No options. Yes, I can change I can pause the print, I can stop the printing, maybe change the filament. It is super quiet, so I can completely imagine this in my working room, so definitely very silent. And I want to show you very interesting that here you can see this bigger gear, which is the extruder, how it rotates much faster because it has some rigid. Oops. I think the first attempt failed. Options, stop the printing, yes. So unfortunately it removed from the bed surface. I have to check the bed leveling again and try again. Let's apply some glue stick. No, I don't want to stick. This doesn't stick at all to the surface. And this just on one corner. One thing I noticed, I try to show you. I go to the bed leveling assistance here. I hope it will be visible. I have a very nice friction here. The second point, same. Third point, fourth point, and in the center, no friction at all. And this I cannot level because it kind of has a stomach or something like that. And here again I have that friction with nothing. And here again I have that friction. So it's obvious that in the center it has some kind of hole or stomach, so it's lower, and this cannot be leveled with this. So that's why I will try to print on this point here, in this corner where the level is perfect. A perfect solution to this would be for something like a BLTouch auto bed leveling sensor, which would compensate the Z offset in different points. I just try to heat up the surface and the bed. After turning off the printer, now it's heating up correctly, so it's working. It started very nice. It's very nice first layer, and the sides also got very nice. This would be perfect calibration cube, but then it just don't stick to printing surface. And just to compare, this one was printed in the center and this in the corner, so you can see it's much closer to the printing surface here in the corner than in the center. So far I didn't have any success with this glass surface. I really tried to level it, I clean it, but unfortunately it doesn't stick. But it's desired dry. Before I try something else with this surface, I will try to print flex filament. This is filamentum flex fill. I have to readjust the spool holder. It sticks to printing surface very well now, this TPU, and I even left some 2mm retraction. It will be visible. I'll try to get it on camera. This on this wheel here, on this bigger gear, and I will even try to speed it up a little bit. So I'm starting with 30mm per second. Other parameters I'm printing on 230 degrees Celsius and 60 degrees Celsius on the printing surface. And I will try to double the speed, so from 30 to 60 millimeters per second. Options. More. Speed. Actually, this is the regular PLA speed. I maybe even saw the retraction on the wheels. And it's finished in 2 hours and 16 minutes. Well, usually TPU sticks better to the surface, but okay, I'm happy that it is finished. And the surface is great, absolutely no stringing. Doesn't stick too good, but it's still okay. This corner was printed with Mingda, and this is now new with the Artillery Sidewinder. I want to try different PLA, maybe that's the reason why it doesn't stick. Looks good so far. Let's see how easy it is to remove. Now it sticks very good. Wow. Okay. I'll wait to cool down. Okay. Very nice surface, so I don't have really any problems with this one. Wow, it also sticks very good. And now it's time for printer to print some own upgrades. And it's almost finished, last 2 layers. Printing surface is 40 degrees Celsius. Okay. That's why I like flexible surfaces. So my whole design was around this idler pulley with the teeth, and it has a ball bearing inside and a 3mm inner diameter hole. I would recommend 5mm diameter, but I only have this type, so my design is around this. But I will also upload on my website the 5mm hole version, in case you have that kind of pulley. I'm locking the position, so in my case this is the final position of this pulley, and I lock the position with these two contra nuts. And this is the mounting, so I have here M5 bolts and these T-nuts, and I can adjust. The tension doesn't have to be too tight, but that was too loose without this. It's not perfect, the color is a little bit different, but it will do the job. In the meantime, I printed these two rollers. They are printed in vertical position, and I use, here you can see it's already cleaned, the sacrificing layer. So you have to clean this layer, because I don't want to use the supports. By the way, they are same filament types, and with this white color I have a lot of problems, and with this one it was perfect. Interesting. The big difference is that this is open now for more than a year, and maybe I could dry it, I'm not sure. So this is opened, I don't know, maybe a few weeks ago. And for the last time I can tie these two bolts. This is my widest spool. And my final thoughts about Artillery Sidewinder X1. First I will start with what I like, and in this order. So I really like this big printing volume. This is the biggest 3D printer I have so far. And I really like that it is quiet, even the fans, so definitely it is quiet like my Pushamar 3S, for example. And I really like this direct drive with this gear ratio, and it is fantastic for printing flexible filaments, for example. And also I like that printing surface will print very quickly. I'm not sure how important is it, and now let's mention a few things what I didn't like on this printer. Well, my biggest problem you saw is the bed adhesion. This solution is quite unique, so AC power attached directly to this glass surface, so I cannot remove it like on Ender 3 to place some different surface. And I'm not the only one who had similar adhesion problems. I saw several reviews and they solved this problem by placing the PI sheet, which is more reliable. I don't have this size PI sheet, but and it looks like it depends a lot from the type of the filament. So I never saw this problem that one filament attached good and the other no, even from same brand. I'm not sure, maybe that one was full of moisture, but this shouldn't affect, so I didn't have this problem before. Since it is very big, I couldn't level it 100% equally. In the middle it is just a little bit lower. It shouldn't be the problem if the adhesion is correct, but I couldn't get good printing here. Maybe, well, actually I didn't try with new filament or in the center. Now, next few things, I'm not sure because I'm only mechanical, not electrical engineer. I'm not sure how good is this AC power heating the bed surface. it is very nice that it can heat up very quickly, but is this really necessary? Because you probably buy this printer to print something big, several hours. Now, does it important that it will heat up in 2 minutes or maybe 5 minutes? Decide yourself. And definitely I will probably print some kind of chain cable guide to prevent the bending or breaking the wire on one spot, because don't forget 220 or 110 volts AC power is going through that cable. And also, I'm not sure, this ribbon cable, it looks a little bit thin to me. I am sure that engineers calculate correctly, but this is not just transmitting the data, but it has to provide some current for extruder or hot end. So I don't know, and I'm not sure that maybe it would be good to secure somehow a little bit better in this position at the end of the cable. I didn't feel any heat on the cable outside, so probably it is engineered correctly, but I don't know, I just don't feel comfortable to using it. And it's a little bit confusing about those printing temperatures. As I mentioned, on Artillery website I couldn't find the maximum printing temperature for the nozzle. On some different websites I found 240, for example on Banggood, but if it is 240, I can set the temperatures on 270. Somebody who is not familiar with this, okay, so we'll see 270 and set this temperature, and that may result some serious problems. And also the bed temperature, it can be set up to 150 in the menu. On the website it says 130, and interesting, okay, so where will you need a 130 or 120, maybe printing some ASA, but you cannot set that big temperature on the nozzle. So do I recommend this printer? In this base setup, not really, but with small upgrades it can be very useful printer. 3 of those you can print yourself, for example these rollers on the spool holder, the tensioner, and maybe the chain cable guide for the AC power of the bed. Now, one of the first upgrades I will do probably is the PI sheet for this, but I have to wait, I know, 2 months to arrive from China. And also you saw I couldn't level the bed so correctly. So for example, this printer screams for BLTouch, because BLTouch can measure the Z offset in several points, and if there is any difference even on one point, it can compensate that in the coordinate in the G code. And you buy this printer to print big. Now, with the provided default nozzle, 0.4 millimeter, to print something which will use the full volume, you will need days for that. So, I don't know, maybe on the website they should offer the option to buy it with the 0.6 or 0.8 millimeter nozzle, because you can print much faster. Just for comparison, 0.8 millimeter is the bigger diameter, but the area is on square of that diameter, and also you can print on bigger layer height, and also you can print faster. So the printing speed with 0.8 millimeter nozzle would be, I don't know, 8 or 10 times faster. And this is volcano nozzle, which is bigger, so you can melt the filament faster, so you can print fast even with that nozzle. So with these upgrades, this is very useful 3D printer, and in that case, yes, I recommend it. But to be honest, it is good to have some other printer for smaller pieces, and this one if you want to print big, but do it with the bigger nozzle. Yes, you will lose some details, but you don't have to wait, I don't know, several days for some bigger printing. Well, that was my experience with Artillery Sidewinder X1. What is your experience if you have this 3D printer, especially with the printing surface? What are you using for the better adhesion? Leave me the comments, please. And I hope this was useful. Thank you for watching, and happy printing!